How would you like? 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 Boy, girl, how would you like to show some of the ways we know? How would you?
Welcome to the project on natural language processing. Natural language processing, or NLP, is the analysis of language produced by humans but by computers. It treats language as a varied pool of information sources in order to both understand language. We might be interested in some cognitive science questions about how language is constructed, but also in order to respond to the speaker appropriately, as in how Siri, may or may not, but hopefully Siri or Alexa or something like that responds to you. Natural language processing needs to be underneath all of that. So there are a bunch of examples such as translation or automated feedback in education or, in shopping as well now. But we do actually use it to study linguistics and cognition and development as well. So it's a very useful tool. It has a very interesting methodological history in that from about the 1930s up until the 90s and 2000s, the dominant way of doing natural language processing was about deriving rules. So it was very closely aligned with linguistics. It was about humans deriving what the rules they thought were inside language and then encoding that in machines. So saying some rule about how a language worked and then getting a computer programmer to hard encode that into a computer program. And someone like Noam Chomsky, who was very much in this camp, championed that as the only way. It was about figuring out the complex sets of rules, the grammar and syntax behind language, and then we could feed that into a computer, and then we would be able to have naturally communicating computers. However, from about the 1980s, there was a separate school of thought that took a very different approach, a very statistical approach, where they just took words and counting words and the statistical relationships between words to infer the rules of language from the data. This often meant that they could not explain what those rules were. They were just statistical relationships. But from about the kind of mid-2000s, or maybe the late 90s, this approach had a lot more utility. So it was a lot more effective than the rule-based approach in products and in actual use cases. And now it is the dominant natural language processing strategy. So if you are using Google Translate or Dragon Naturally Speaking, or you're communicating with Siri or Alexa, then you are taking advantage of the statistical approach to natural language processing. Like I said, there's a bunch of different companies involved in this, and quite a few in the education space. The NLP in the education space has been very much dominated by essay graders and plagiarism detectors, but now we're getting to see some more kind of slightly more learning-focused products on the market, and there are also a bunch of research-based products such as Cometrics, which tests essays and documents for their easeability, of how easy they are to read. The essential problem in natural language processing is the heterogeneity of the data. Language is very different depending on where it's being documented, depending on what kind of purpose it's being used for. So if we think about writing in a tabloid is going to be very different from writing in a textbook, even though they might be about the same topic. And in education, historically, we've gotten rid of all this heterogeneity by using multiple choice questions. If we restrict the possible answers, then we kind of don't have to deal with this heterogeneity. But in doing that, we do lose a lot of information, a lot of the complexity of how a student or a learner might be thinking about a topic. And so there has been a push towards getting better natural language interaction with students through machines, because there is a hope that will open up the ways that we can assess and develop people's skills. So the overall method is the kind of 40,000 foot view, is that we have something called student understanding, something that exists in the head of a student or a learner, and we're going to capture their response in either speech or in writing. So if it's in speech, then we then have to take an extra step of writing it down. But eventually we'll have a corpora of student responses. We'll have hopefully a range of different responses to the task that we are interested in analyzing. We're then going to do a lot of pre-processing. So NLP is at minimum 80%, but probably more, pre-processing the data to make it usable. So that can involve human coding, but it often involves a thing called the bag of words approach, which is to cut words into their smallest unit of meaning so that they can be analyzed. Once the pre-processing is done, then we might apply some kind of algorithm, some kind of statistical approach to capture the signal. If we think of the pre-processing as trying to cut down the noise so that the algorithm can detect some kind of signal, that we can then use that trained model to do some automated task in the future. So that's the kind of overall approach. If we think about it, we're really talking about taking a proxy of a proxy, because the pre-processing is going to involve some kind of interpretation of words. So we'll look at that in a second. But also the algorithm is a second layer of interpretation. And since we can't really see what's inside the student's head, there is a long chain of inference here to kind of make some kind of statement about what we think a student is thinking. So you can get quite a long way in NLP just by counting words, and even just by looking at the most common words. So here's a picture where each country is represented by the word that is most common in their Wikipedia entry. If you've ever seen the Google Books Ngram viewer, that is the probability of a word appearing per year. So you can look at the trends of the most common words, or the commonality of words over time, and see how that changes and words come in and out of fashion. The next step, though, if you're not just going to count the most common words, is you probably want to take what's called a bag of words approach, where we do a process called tokenization, which is where we take sentences and we chop them up into their most atomistic, their smallest unit of meaning. So in the first place, we're going to remove any punctuation. Usually punctuation isn't giving us much, so we throw that away. Then we want to find the best number of letters to represent a word or a meaning, and we're going to do a process called stemming, where we take the root of the word. So the words educate, education, and educating would all be collapsed into the same root, so educ or something like that. Then we might want to consider all possible versions of a word or a phrase. So here I've said I don't know and I dunno. They're two similar expressions, and we want to probably collapse those into one thing so that they don't get counted differently. The last thing is a bit of an art, and it's called stop word removal. So there is no definitive list of stop words. These are words that do not contribute to meaning a lot as far as the computer is concerned. They're often words like and to and but, which humans need but don't bias a lot in a statistical analysis of the words. So they are often removed, but they really depend on the context of the analysis. Once we've got all that, we can start to develop features from our words, and we will apply some kind of algorithm to do that. So here's a very simple example that you will be doing in the project, which is sentiment analysis, which is to kind of identify and categorize words according to some aspect of sentiment. So sentiment could be happiness or positivity and negativity or anger. Often you'll see trends of different sentiment across Twitter over time, and this is probably using this particular strategy. So in this case, we're going to take a bunch of text, we're going to tokenize it, we're going to cut it up into its units, then we'll remove all the stuff that we don't think is useful. So that might be the punctuation, and then we will remove stock words. So here we've removed I and this, and then we're going to classify whatever words are left over, love and class, and we're going to use a lexicon or a dictionary that is pre-classified. So all the words in the dictionary get some value according to the thing we're interested in, so positivity and negativity, and then we can, I've said train a model here, but really all we're doing is counting up how many positive and negative words there are in the document, and maybe we're taking the average of those so we can know how positive or negative a document is. A more advanced algorithmic approach to analyzing our bag of words is a thing called topic modeling with latent Dirichlet allocation. Topic modeling is a type of statistical model for discovering the abstract topics that occur in a collection of documents. Here I have a picture of a rack of magazines that have been ordered according to their topic. So at one end we have entertainment type magazines. At the other end we might have fishing and hunting magazines. Somewhere in there there'll be music or architecture or style or whatever. And we can kind of intuitively look at a magazine and know what category it belongs to, but what we want to know is, can a machine do this for us? In order to do this, we utilize several axes of variation across our bag of words. So we can think about words that we observe in a document, and then a topic is really a distribution for words in a document. So I will go into more detail, but that is our first axis of variation. We are thinking about the distribution of words across a document, so how often a word appears in a document. And then we can also look at the topic distribution over a document. So once we've defined the topic, we can say, well, what kinds of topics might be involved in each document. So if we go back to the magazine example, yes, a magazine, we might categorize it as belonging to entertainment, but that doesn't mean that there's nothing in there about fishing or music or something else. So each document contains a range of topics. It might contain one dominant one, but it can contain several. And so what we want to look at is both the distribution of topics across the document and the distribution of words across a topic. So each topic will be made up of words, and each document will be made up of topics. Another way of thinking about this is in these three tables. So in the top left table, we have documents in the rows, and in the columns we have words. And in the cells in between, we are saying the probability that a word appears in a document. So how often that word appears in a document. And from just looking at this, we can see that document 1 and document 2 might cover a similar topic, because the word cat and dog both appear in those documents, but they don't appear in document 3. So just from this table, we might think that document 1 and 2 are more closely related by a topic than document 3. The other thing that we can look at is the probability that words occur together. So we can see that in the right-hand table, we have words in the columns and in the rows, and then in the cells, we have the probability that a word occurs with another word. So we can see that the probability that dog appears in a document with cat is 0.2. And the probability that cat appears in a document with the word corgi is 0. But the probability that the word corgi appears in a document with the word dog is 0.5. So the way that we can use this now is in the bottom table. And so we can see that although the word cat and dog do not appear in document 3, the word corgi does, and therefore, because corgi is related to dog, maybe document 3 is not as far away from document 1 and 2 as we had originally thought. So these are the two kind of pools of variation that we can draw on to allocate documents to different topics. And topic means a very specific thing. In LDA, a topic is a probability distribution over words. So we take all the words across all our documents and the entire corpus, and we say, what is the probability distribution of every single word for each document? And then each document will get a characteristic distribution over words. And then we can look at the similarity of those distributions to see whether documents belong together within a topic. So a document can be described by a recipe of topics and also by the distribution of words within that document. So what does LDA do? LDA assumes the documents cover particular topics and particular topics are covered by particular words. and therefore we can group similar documents by their word profiles which represent topics. And LDA is a way of calculating those distributions. It's a bit like cluster analysis, but for words, and it also requires that you define how many topics you think there are in a pool of documents. The person who came up with it was Peter Dirichlet, pardon me for my terrible pronunciation, who was a German mathematician who also helped come up with the definition of the word function. So, he's a pretty heavy hitter. And the Dirichlet distribution is a probability distribution of probability distributions. So that's why it's useful here, because we have these two interlocking probability distributions of words over documents and words over topics. The workhorse of LDA is the term document matrix or the document term matrix, depending on which thing is in the row and which thing is in the column. Term frequency is the number of times a word appears in a document, and the inverse document frequency is the number of documents in the corpus which contain the term. And these are kind of the workhorse values that we use to calculate LDA. So if we have both the words and the documents, we can define topics, and then we can use those topics to predict the topic of a new document that we haven't seen. And that's what happens whenever you get suggested things in reading lists or on the news. You liked this article, you may like this other article. They're probably using something like LDA to discover what the relationships are between those articles. So in this project, what I want you to do is to use student notes. These are just student notes from this class that students wrote about the readings. And then I want you to pre-process that text data. There's a lot of pre-processing that needs to be done. Then I want you to map sentiment to these documents and look at that over time and see if it changes. And then I want you to use LDA to discover if the common topics within those documents. Good luck. Don't forget to like and subscribe. I'm kidding, don't do that. Don't like or subscribe, please. Don't.